Hi students, in this video we are going to learn about weighted resistor digital to analog converter. One of the simplest circuit is weighted resistor DAC. So this is the circuit diagram. Normally it uses summing amplifier with weighted resistor network. Okay, so this is the summing amplifier and this one is the weighted resistor network. Weighted resistor, what is the meaning of weighted resistor? Means we are giving the resistance value is different, that is 2 power 1 R. This is the first resistance, that is 2 power 1 into R, then 2 power 2 into R, then 2 power 3 into R, up to 2 power n into R. So that resistance value will be different, that weightage value is different. So this is called weighted resistance. Okay. Here we are using n number of switches, that is electronic switches D1, D2 up to Dn, n number of electronic switches that is controlled by the binary input word. Okay, that electronic switches are controlled by binary input word. So that if the binary input is 1, that means it connect the resistance, this resistance to the reference voltage VR. Okay, if the binary value is 1 means this switch is connected to reference voltage. That means the resistance is connected to reference voltage. If the binary input is 0, then the switch is connected to the ground. Okay, to find the output voltage, we are assume all the inputs are high. That means all the binary inputs are 1. That means all the switches are connected to the reference voltage. For the calculation, we are taking like that only. Okay, here all the switches are connected to the reference voltage. Let's see the output voltage value. Okay, so here to find the output, assume all switches are at a closed condition. That means binary inputs are 1. Then the output current of an ideal op-amp. What is the output current? So here I0 is equal to, so here if you are applying KCL, I0 is equal to I1 plus I2 plus I3 up to IN. Right? So first we are going to find I0 value. So just we are using the Ohm's law. So I0 is equal to V0 minus, here the voltage difference between the resistance is V0 minus VA, right? So that is V by R, V0 minus VA divided by RF, that is I0. Okay, so I0 is equal to V0 minus VA divided by RF, that is equal to I1. Then what is I1? I1, the resistance voltage difference is VA minus VR. The reference voltage is negative, right? So VA minus of minus VR divided by 2 power 1 into R, that is I1. Then what is I2? I2 is equal to VA minus VR divided by 2 power 2 into R, etc. plus IN. What is IN value? VA minus of minus VR into 2 power n into R. Okay, can you understand? So here this is the value. Then here this is virtual ground. So here VA is equal to VB is equal to 0. Then here we are substituting VA is equal to 0. Then what is the value here? VA is equal to 0 means V0 divided by RF, that is equal to VA 0 minus into minus plus, that means VR divided by 2 power 1 into R plus VA 0, that is VR by 2 square into R plus etc. VR divided by 2 power n into R. Okay, so here VR is common term, VR divided by R is common term, so take outside. Then this value is VR by R into this value. Then from this find V0 is equal to VR into RF divided by R into this value. Okay, so we are assuming RF is equal to R. Then what is the value of V0? V0 is equal to VR into 2 power minus 1 plus 2 power minus 2 etc. 2 power n. Let's see the transfer characteristics. So here the transfer characteristics between digital input and the analog output. So here this is the voltage to, digital to analog converter. So the transfer characteristics between digital and the analog output, digital input to the analog output. So if you see this graph, we can say this is the analog output will be positive staircase. Okay, here the analog output is a positive staircase because we are giving the reference voltage is negative. The circuit reference voltage is negative, so the output of the analog is positive staircase. Okay, here we are using the summing op amp. That summing op amp may be inverting mode or non-inverting mode. Okay, using the op amp is inverting or non-inverting. Then what is the circuit accuracy? The circuit accuracy and stability depends on the accuracy of the resistor used in this circuit. Which type of resistor? What is the resistance value? What is the weightage of the resistance? Depends upon that we can say the accuracy and stability of the digital to analog converter. Okay, next let's see the disadvantages of the digital to analog converter. So first one is wide range of resistance values are required. So we know we are using weightage. We are giving the weightage is very high, 2 power 1 to up to 2 power 8. If we need 8-bit DAC means 2 not R into 2 power 0 into R to 2 power 7 into R. We are using this type of weightage. So here number of bit is increases and the range of resistance values also increases. 8-bit, if you are using 8-bit DAC means the weightage of the resistance also increases. That is the disadvantage. Then another one is the input binary word length has to be increased, which has required wide range of resistors. Same one. So binary word length, if you have binary word length is increased means requirements of the resistance also increased. Then fabrication of large resistance in IC is not practical. Okay, the voltage drop across a large resistance affect the accuracy. So these are the disadvantages of weighted resistance digital to analog converter. I hope this video is useful to you. Please subscribe to watch all the upcoming videos. Thank you.